let us do some further revisions on our existing code and also do some cleaning up. To begin with, our drop-off areas now are kind of difficult to see for the player what they're supposed to do, right? You need to read the text and it's not super clear and obvious. What we could do is we do something more visual. We can, for example, we could have that the object that you drop in a certain area is hovering above the area, so you see that this is the place where I should be taking this item, just for clarity's sake. So if we go to drop-off area and then we add a, let's see, we want to have this one excuse me, we want to have this one under the default route probably, and we type in a static mesh and we say display pickup item, display item to drop off, and it's super descriptive. And we will start off with a 1m cube, just so we have something, and then we'll drag it up a bit. So this will be replacing the text eventually when we have something that we're happy with. To start off, maybe we want to remove a collision for this object because we just want it to have just exist as an indicator. So mark the mesh in the top left, and then we'll go to collision and collision presets, and we'll go to no collision for this object. In addition to that, maybe we want to have something of a flare when it comes to this object. Maybe we want it to be rotating a little bit so that it's visible. So if a person were to stand still from any angle, they would eventually see what the object is, because the object would be rotating around, right? So let us do something like before. We have a timer that changes for scanning. Maybe we want to set up a different timer. We can call this event rotate display item, and we will hook those up. And it will be looping, and we'll set a time for, let's promote it to a variable. Good habits are good. We'll call it display item rotation event. So we want to have this item rotating, maybe let's say let us do something else. We haven't been using timelines a lot, so let's do that instead, just so we get some practice with that. So we remove the timer and the custom event we made, and we can rename this variable to be something like display item rotation interval or something along those lines, meaning that this is supposed to be how many degrees it should be rotating per update, basically. So let's do a timeline, and we'll call it rotate display item. We will enter the timeline, and we will, let's say we want to make a full rotation in 4 seconds. So we'll put the length to 4. We will make a float track. We will name the track rotation in I was gonna type percent, but that's not entirely correct if we are using from 0 to 1, but it'll be fine for now, I think. Anyway, so we have named that. We need to add some keys. We add one at the start and one at the end. You don't have to be super specific because we're gonna be realigning these now. So the first one is gonna have time 0 and value 0. The second one is gonna have time 4 because that's the length of the track, and then value 1. And then you can press these buttons here to get a good alignment for them. And the completely linear rotation should be fine. And we go back. And now we want to have, first of all, our display item to drop off. We want a reference for that one, and we want to rotate. And let's say that we set a relative rotation because we want to be rotating inside of this hierarchy that we have right here. It shouldn't matter if we pick the world one, it should end up correct either way. Although, now that I think about it, this is not very good because we will just be running this once right here. So what we need to do is go back into the timeline. Make sure that loop is set. And compile. And from here, what we want to do is we want to split the new rotation struct, so we get our 3 separate values. And we want to have our rotation, which should be, since we said that it was gonna be a full rotation, a full lap around its axis in 4 seconds, and this timeline would output a percentage. That means that 360 degrees, which is a full rotation, is the value that we want to have as our rotation for now. We want to multiply this float by float, so we get the percentage in here, and then we set our rotation to that as our new Z rotation. Let us see what that looks like now. There we go. That seems at a good pace, I think. So, now then, to fix these up and also clean up some things, we go to the fire extinguisher drop-off. Have we not renamed the areas yet? Let's do that first. We have a lot of cleaning to do. So, drop-off area blue, we want to rename. And the blue one is the one that we renamed to engine, I believe. And the red one is the fire extinguisher, so we renamed that one as well. Extinguisher. There we go. And then we can go to our drop-off area for the fire extinguisher. Compile, save, and open it up. And what we want to do is we want to replace the display item with our fire extinguisher. Static mesh. There we go. And then for the blue one, or the engine one, we do the same thing. Did I open up the wrong blueprint here? I'm getting a pickup. Let's see here. There we have the engine one. And then we type in engine for its mesh, the one with modify pivot, because we want it to have the proper pivot in the middle so that it places itself properly. And let's give this a try and see what it looks like. It looks okay. Maybe we want to put a little bit of a flare to this. Maybe we want the engine to be slightly transparent so that we see that this is just a template of like the item that it's supposed to be having. And a way we could do that is to we can go to meshes, find our engine, and let's open up the engine. It has a truck engine texture. We could change this one. Let me just double check quickly with the fire extinguisher what it looks like. So it has one for fire equipment. Okay. It should be fine, I think. So press the looking glass to get to where the material is. We want to make a duplicate of this one. We call it... we put a display as a suffix for it, so we know that that's what it's about. And then what we want to do is we want to find the okay. You know what? Let's roll back on that one. I'm not too happy about how this has been set up, so this is going to be a long video as it is enough with all the different parts, so we'll cut out some of the features so we don't get too much of a scope creep. Having the engine and the fire extinguisher rotating should probably be fine. We might want to scale it up a little bit because the fire extinguisher is sort of small. So we'll go to the drop-off area parent. So we can scale it by clicking the lock and then doing 2 times, let's say. Then bring it up a bit, and then after that we want to remove name, because we're not going to use name anymore. First we might want to remove the text render, and then the name. Want to delete it? Yes. Compile, it will say we have an error. We'll click where it is. We'll remove this from the construction script. There we go. So now we have all of these without saying names. We have these objects hovering about them. It seems okay. Another thing that we should clean up is probably our pickup, because we had a bit of functionality that we never actually got to use. Which is, if we go to the pickup parent class, we have this set person holding object, and we didn't get to need that, so we'll remove this event. We can remove the variable as well. Compile, and we should fine here. However, there should be a call to that. Where's the first person character? You see it has an error, so we'll click on where it has the error. When we pick up an object, we set this variable here. We remove that now. There we go. We compile and go to the next error. We'll bypass that one as well. Compile and go to... There's no more errors. Excellent. Okay, so now we've cleaned that part up. In addition to that, we can go back to our drop-off area base. You can also, if you want to go to the base parent class at some point and you just find one of the other drop-off areas, you can always just go up here in the top and you see which the parent is, and you can either click the magnifying glass and get to there in the browser, or you can click the little wrench and you'll immediately open up the blueprint. So we know that we have some debugging information that we're writing here, like the scanning text here on scan for objects. We can remove that one and reconnect the execution pin. We can remove the finished scanning. We also have one here for desired pickup found. We can remove that one, reconnect it again to the sound. There we go. In addition to that, we also have some debugging in our first person character we should clean up. First person character is over there, and that's related to our trace scan, I believe. Let's see if we can find a function here. Trace for pickup. We have set the draw debug type to be persistent. We can say none on that one now because we're happy with it for now. And that should be that. And lastly, we will look at our fire extinguisher. And by that I mean our fire extinguisher. So if you find either the mesh for it, the fire extinguisher, and then you click on collision and simple collision, you can see that we have a box around this, which is fine, I guess. But since we're messing around with physics, it would maybe be more fun if it was actually maybe cylindrical. So we will mark the collision box and press delete. We'll go to, that was wrong, we'll go back and go to collision and add a capsule, simplified collision. That seems better, although we might want to scale it slightly, right? Because it's a little bit big maybe. So something like that should still be encapsulating everything. Press save, go back out, and let's see what happens when it falls off the conveyor belt here. Okay, it's falling over a little bit better now. Before, when it was a box, it didn't really want to fall. It mostly just ended up standing like this. This is a little better in my opinion. Let's work a little bit on lighting now. What we currently have is a light source of directional light that's sort of representing the sun, which is fine. However, we want this to have sort of a warehouse kind of feel, right? So we want to have a roof over this. So if we were to take a roof, and I'm just gonna rotate this simply because I want to make this easy for me right now for demonstration purposes, and we'll scale it up. Let's see, we want to scale it along X and Y, so let's say 5. Is that enough? That should possibly be enough. So we will move this so that it's covering everything like so. That will be our temporary roof, but later on you can make it pretty as well by putting singular objects of meshes every here and there, so you get a nice roof to look up at. For now, a few of the things, let's see if we move that down slightly, like so. So one of the issues with this is that it's difficult to work in this kind of environment because everything is dark. If you change up here from lit to unlit, you can see what it looks like without any lighting being affected, which is good in some circumstances, but for now we want to actually add some lights. So if we start off with going to lights up here in the top left, and we take a point light, that's sort of like a light bulb, which is why this is a good icon for it. It has a very omnidirectional light, it goes everywhere, and that's also what you see here by the sphere that it's outlining. If we actually go back to lit now, you can see better what kind of an effect it has. So with this you can play around with things like what kind of a light it should be emitting, if it should be like green, red, yellow, whatever. White is usually the best, I think, unless you want to actually convey some sort of mood, but this is a warehouse, so for the most part we would have lights that are white, and maybe at some places we would have lights that are yellow, green or red to indicate something like danger, or something's working or something's not working, and things along that line. But for now we'll make some white lights. And in addition to what kind of color the light has, you have things like attenuation radius, which is the radius that we currently see here, so it's sort of a fall off for the light. In addition to that, you have intensity, which will directly affect its power, meaning how strong the light is. And you also have some other things to play around with here, which are not super important because this is not going to be a lighting tutorial. But yeah, what you might want to do now is that you drag around a few lights in this place, sort of symbolizing having lights fixtures in the warehouse, and put them out so that you have some good spread of them so that you can see properly enough to argue that this would be the kind of lighting that you would have inside of a warehouse possibly. This might be a poorly lit warehouse, maybe we have economic troubles, who knows. But yeah, basically something so that we can both see the scene and feel like the player is not being denied information, because this is not a horror game, right? So we want to have the player actually see things that are important in the warehouse. So now we have a fairly good cover along the edges, I would say. We can put some in the middle as well, so we get to see some things that are not along the edges. Something like that. Now we have a warehouse that looks sort of illuminated, right? If we press play, it should be decent enough. If you get this lighting needs to be rebuilt, best way is probably to go to light source directional, change it to movable, although that's not the only light apparently that's being affected by this. Also the other light fixtures are being taken into account. To go into it slightly, when you have a static light, it means that you're going to have that light at that position at all times. So what the game wants to do, it wants you to build the lighting, which means it builds, it bakes the light, it's called, which means it sort of calculates how the light is gonna look before the game starts, so that it doesn't need to spend any computing time on that. And the reason for that is because you get performance gains, of course. But for us, this is not going to be that demanding, and this will make it a little bit easier for us if we just mark all the point lights that we have put out and we click them as movable. That means that the building of light message disappears, because now it's expecting this to be calculated all the time. Generally speaking, I don't like to teach poor behavior, of course. Good behavior is always good, but I'll consider it fine if I explain why. And since you now know the reason why we have movable objects, movable lights instead of stationary, and you know that that's better for performance reasons otherwise, then you have that in your tool box, so you can make the determination for yourself in the future. And also, if you run into this problem, you know why it's happening, so that you don't want to maybe rebuild all the time, because you could also be putting in a lot of lights to test something out, and maybe then you don't want to build the light, which might take a while every time to test. So then you can have movable just to more quickly get an accurate depiction of what the light would look like. So now I figured might be a good time to actually build a little bit upon our layers again if we want to. I was thinking what we could do are things like we could have this machine here be representing our spawner, and maybe it needs resources to function. So it needs metal and bolts and things like that to be able to continuously churn out new boxes. So by adding another dimension to the game, not only picking up things and delivering them, you now also have to go around possibly picking up resources somewhere around on the map to continuously refill the machine so that it can keep churning out these boxes, so you can keep delivering the boxes. Another aspect I was thinking we could possibly add to this is having this fuse box or electric box be sort of a feeder to this machine as well. So we could possibly like hook these things up, so that as long as the electric box over there has power, then this machine would still be churning out boxes along with its resources, of course. But in order to have this one continuously giving it power, you sometimes need to go and knock a little bit on the side of the box just to make sure that it's still feeding energy. And if at some point the electricity was to run out, then maybe we would have a light that's turning from green to red, indicating that something's wrong here, and maybe a red light over here also indicating that something's wrong, that you'd have to go over here and fix that before it can get more boxes from the machine. So let's start doing that. we can start off with making a new blueprint. We can call it, we make a blueprint of type actor again. We call it BP underscore and we call it collectible resource. And like always, we want to have some kind of representation in this one so that we see it out in the world, and then we can build upon that further. So we'll pick a 1M cube for now. And generally in games you have you can convey to a player generally that this is a pickup by having something like glints of light maybe, or an outline, or having it rotate or something like that. Something to communicate to the player that, hey, this is something you might want to run up to and interact with. So let's do that. But first we can add a, let's put it on the scene root. We want a box collision again, because we need to have a volume around this item which allows us, we call it proximity volume. We want a volume around it to indicate or to detect a player entering the area, right? Scale it up to, well, this is going to be difficult since we're going to be having items of different sizes possibly, but we can maybe assume that this is a good size, and then we reset the location again, so it's inside here now. Let's maybe make it a little bit larger so we can see that it's there. We can be fairly generous with the area around a pick-upable object, since we don't want it, the player generally to have to go like on the exact pixel where the object is, right? We also go to the mesh and we change its block preset to be no collision, because we don't want the player to be stuck on the object or have any such issues. We're just interested in the volume to determine if a player enters. And other than that, we want to have our static mesh rotating, so we'll go back and do something like that. And since we did a timeline last time, let's do a timer by event this time. Custom event, just to switch things up a little bit and get you playing with all different aspects of like having interactions. Rotate collectible, and we drag in the proximity volume. We hook up the event. We say it's looping. We say it's like every 0.1 seconds maybe. And then we rotate this, relative rotation, set relative rotation, and that might not be great because now we're actually having this with a timeline. We could have set it because we would have an input which we would be multiplying against, but for us we're gonna be adding now instead, so add relative rotation. So each time this is called, we add it with a certain amount of degrees, right? So we add a variable saying amount of degrees to rotate and make it a float. Then we can compile so we get a value there. Let's say we do 5 degrees or something like that. And then we bring that out here and we split up the struct here because we only want to rotate around one axis, and like always, almost, we want to rotate around the z-axis. And that should probably be it. So let's try this out and see what it looks like. We put it in here, drag it up a little bit, and we play. Okay, yeah, it's not rotating, of course, because we are rotating the wrong object. Yeah, proximity volume. We want to rotate the mesh, of course. And let's go with that. So there you go. So it's rotating. Now this doesn't look that smooth, which might be an issue, maybe something you don't want. either changing the amount of degrees that we rotate or using a timeline would make it smoother. Either way is fine. We can do something like 2 degrees, or we can also change the amount of times that it's being called. There are different ways to handle this kind of rotation. So it's all up to you if you want to have it smooth or a little bit choppy like this. Yes. Arguably a timeline is gonna be nicer. Let's actually go back to doing that. I regret everything. Timeline and rotate collectible. A full rotation, a full rotation around its axis as the rotation in degrees there. And then we'll do what we did before, which is let's say that this is 4 seconds as well. Then we have the floats. We name it rotation in percentage. Create 2 keyframes. Put the first one at 0 and 0. The second one at 1 and no, 4 and 1. And we want this one to be looping as well. Compile, go back. And then we need to do the actual rotation. So we take our mesh and we set relative rotation. We split. I'm sorry for doing this a little bit faster now because we've done this several times. If you need to pause, you can just pause. But this should be finally fairly okay for you to follow along with, I think. Considering we have done it multiple times. And also you have the power of the YouTube, which means that you can pause it at any point when you want to, if you're need to rewatch or falling behind or something like that. Let's check it out. Okay, it's rotating smoothly, looks fine. We now go back to our proximity volume and we go down to the bottom right and we say on component begin overlap. And we need to check if the other actor is a first person. So we cast to first person character. Now we need to do something when this happens. So we need to actually have a resource on the first person character which it can actually increase with this. So let's go back to the first person character. Let's call our first resource metal. And we will give it a float value. And then we need to have some sort of way to increase this. So we will make an event. Increase resource metal. I'm considering making this a little bit more advanced and reusable, but I think we'll keep it a little bit more inefficient and easy, and instead of adding new features all the time, because the scope creep will just keep on growing. It will have an input that will be an amount. We can even call it an amount to add, so we know what we're going to be doing with it. And then we'll say our resource materials should add plus sign float plus float this value, and to make sure that we have an acceptable value, we can clamp the float. So we'll also make a variable saying resource metal max. So we have a max value that we can't go beyond, and let's give it an arbitrary number. These are easy to just adjust afterwards as you would need them, which is why we make them. And we put our resource max there. So this means that we're not going below 0 and we're not going above the max. And then we set our max. Not our max, that's completely wrong. Set our current resource metal to this value. So that's that. And then we need to we will go to our character, no, not our character, our collectible, and we will make an event called picked up resource, and then we will call it afterwards here. Resource, it's not showing up. Picked up, there we go. Spelling is key. And this resource may want to have a parameter of first person character so that it can know who's the player that picked it up. Who picked resource up, so that we can do something with that. And we'll hook that up there. Since this is going to be a parent class just like we've done earlier, this is where we're going to leave it, because this function here doesn't do anything on the parent class, but we will be overloading or redefining this method in the children, so they will be doing something with this instead. So to demonstrate this, let us build a child immediately and see what that's like. So we will create a blueprint class child, and we'll call it resource metal. And we go to its functions, its events, sorry, and we want to show inherited variables. Okay, that's fine. Then we'll go here and we see that we have a few events already called here, but we want to, let's see, we made it, what did we call it? Picked up resource. It appears under function rather than event, but yeah, so this is where you can find the override, and then you can see a picked up resource event, which is the one that we did earlier. And this one will be using the what did we call it? Something metal, increase resource metal. So it will increase it by something. So let's say we have a variable that says amount of metal. Rather, let's not do that. Let's go to our parent class and give that one a variable that says amount of resource. So it's generic enough that it could work for any kind of resource, and that means we have it available here now, and we'll just put it in here. And then we can have a default value of, let's say, 5 or something like that. Okay, let us do some debugging. We can go to our first person character again. It's over there. Make sure that every time this is increased, we actually type out whatever amount of metal that we have. Like so. Just as a debug to see that it was working as intended, so we pick up any errors that we might have made early on. So this is not a metal, this is just a generic parent class which doesn't do anything. So we'll drag in 2 metals instead here. There we go, and then we'll walk over those. You see that we get 10, 5, 10, 15, then 20, 25, 30. And the reason for that is because our first person character has 3 different components on it. So whenever each component enters the volume, that means it gets called, the overlap gets called each time for each of those events. Sorry, the event gets called for each of those components, which means that we get a resource 3 times. Since we want to get rid of our resource when it has been picked up, we can do a destroy actor when it has been picked up. And by doing so, it should only be picked up by the first component, and then after that it shouldn't exist anymore, so it shouldn't be a problem for the rest of the components. Now you can see we pick up 5 and 10. Like we have said many times so far in this series, there are many ways to solve each problem, and some are better and some are worse. This is a quick solve to the solution, solve to the problem, because we're gonna do this anyway, right? I want to apologize a bit because I've been doing a lot of mistakes, and it is because I'm a little bit feverish, so my thinking isn't 100%, but I think we will get through this anyway. So let's continue. Let's go into our beep collector for the metal and change the static mesh. I had figured there is something like a metal barrel here. That looks like it could be fitting as a an object for picking up. I do, however, need to remove some of these blueprints because there are so many and I'm having trouble finding the ones I'm after. That one should be fine. Yeah, I'm sure that's fine for now. Anyway, so we have the mesh selected in here and outside in the navigation, so we'll just drag that in here and we have our barrel. So our barrel will be looking like that. We might want to not move the barrel but move the proximity volume, perhaps, something like that. Now we need to figure out how to get these items out into the world, and we can do something similar to what we've done before. We can make something, a new blueprint. We can call it, we can make it of a type actor, and the BP underscore resource spawner. So this will be similar to the one we did before, but a little bit different as well. So the first thing we want to do is we want to add a variable of what kind of a class we will be spawning from this. So if we pick resource class as our name and then change the type over here to be a BP resource. Is that not what we call them? Collectible resource. BP collectible resource. Since we're picking class reference now then. So if you place an object like this in the world, the idea is that you place it out here, like so, and then you say this object should be of the type, let's see here, okay, we need to expose it first, sorry. Let's go to our collectible resource, no, sorry, our resource spawner, and we will instance editable this one so that it is visible. That allows it when we select it in the world, we have a default class that we can pick here, and it will only allow us to pick among the collectible resources that we have created because we took the parent class, just like before. So we can choose this one to have like metal, for example. And then inside this class, we can say that it is going to we create a custom event. Spawn resource class, and this event we will spawn actor from class. We will choose our resource class that we have selected for this, and that should be pretty much it. We can get the transform here, can be our default scene root, get transform, actor, get owner. No, I want to get the transform. Why am I not getting a transform? Get world transform, I want to get a world transform. There we go. I'm not sure why that was so difficult for me to find. Anyway, we'll translate that in there. So that means that if this event is somehow called for this object, then it will spawn a metal resource over here, is the idea. and then you can place multiple objects like around in the world here for all the different places where you want to spawn it, and then that will be handled by that basically. However, we want to have something that manages this as well, so that we make another blueprint, bp underscore resource manager. And what this one will do in the beginning is, on the begin play, this is something we have spoken about before, get actor by class. It is something that we want to avoid doing, but it is okay if you do it under controlled circumstances. Like for example, we want to do this only when this actor is created, and then it will keep track of them after that by promoting this to a variable. So we'll call these resource spawners. That didn't go very well. Let's try that again. Okay, resource spawners. And we want to select the BP type resource spawner. Okay. So now this manager needs to, even though it doesn't have any representation in the world, this one is a completely empty object other than this scene root and the code we're putting in it. It still needs to exist in the world. So we need to drag it out and place it somewhere, because this class will be the one communicating with other classes, making sure that they spawn stuff, right? So let's try and debug this a little bit. Always good to keep debugging with short intervals so that you don't do too big of a chunk of code, and then when you try to get it to work you have no idea why it's not working. You want to have small increments of checking regularly that your code is still functioning like you want it to. Anyway, so let's say that we have a let's create an event. Sorry, event timer, set timer by event. So we want to have an event, and this event is supposed to be calling spawn resource at spawner. A bit redundant, but hopefully it's understandable. And let's say that we do this every 5 seconds or something like that, and we do it looping. And what it will do is it will get a spawner from the ones that it has found in the beginning. And let's say we do a random array item. So that means it will get a random one and return it. And on this one, we want to say spawn actor from class. Is that what we called it? No. What did we call it? Spawn resource class. That is not what it's asking to do. Let's see here. We get an actor object reference. Okay, so it's not. It doesn't know what to do because it's not of that type. So we'll do a cast to resource spawner. And then we say spawn class, spawn resource class. Okay, so when this actor is created in the beginning, it will pick up all the resource spawners that we have put in the world. So it will dynamically work if you put new resource spawners out into the world, or if you delete them, because this one is run every time that the level is started. It will then create an event by a timer, making sure that every 5 seconds it will be calling one of these random spawners and say, hey, spawn your resource. Now, if we already have a resource there, maybe we don't want to spawn it. So let's go back to our resource spawner, and then we'll give it a variable saying has already spawned a resource. Then we'll make that a boolean. And this will be by default false. And once we have spawned this actor, we want to set this to true. There. But in addition to that, we also want to make sure that when this actor is picked up, we want to know that it has been picked up so that we can allow ourselves to spawn a new one in later on. Which means we have to do an event dispatcher. So this is the class that wanted to receive something, and the sender will be a collectible resource. So what we could do is we could make it here. We make an event dispatcher called resource picked up, and then we'll call resource picked up. Means that when someone has picked up the resource, we're gonna say, hey, I've been picked up. So let's see here. That means the resource spawner needs to make sure to assign resource picked up to an event. We do that here, like so. And the very first thing we do is we unbind. We want to let's see. First of all, we rename this one to was picked up, like so. This one still wants to have the reference to the object if it wants to unbind it, so we need to send in the object itself as a parameter. So let's see here, we have our resource over there, and we'll change our inputs to have a in parameter of BP resource. No, BP collectible resource is what we call them. There we go. And then we'll call it picked up resource. And compile, and it gives us an error because it doesn't recognize a signature anymore. That's not a big problem. You just right click on the node and you go up to refresh nodes, and it'll fix that up. And we send in self in here, and we compile and save. So now we're sending that we are the ones who got picked up, which means that the resource spawner now gets the parameter in here, and let's refresh that once we get the proper signature, and then we'll say this one unbind picked resource picked up, so that we only listen to it once, and then we have to start listening to it again when we spawn a different actor, a different resource basically. And we also need to set this one as false again, because now we haven't one spawned already, because we just found out that it was destroyed by getting picked up. Is that all we need, I wonder? Let's give it a try and see what happens. So currently we have this place over here. That's the only place where we have put a spawner, and it should be putting a metal spawner over there. So if we start playing, let's see, select the viewport, there we go, and then we go over here, and now the timer is 5 seconds, which isn't optimal, I guess, but there you see that it spawned in a metal object, and if I pick it up, I got way too many resources, but we'll look at that in a moment. And then you see it respawns again here after 5 seconds because it oh, maybe it's failing and we are spawning multiples here. Let's try by letting it spawn one. Yes, we are spawning multiples. Let's see what we can find out about that. So likely it's our resource spawner that's the problem, I would think. So we go in here. Okay, so we have this being set and checked, but we don't actually verify that it's allowed to spawn something. We need to actually get this and have a branch by pressing B, making sure that has already spawned the resource needs to be false, or else it will keep on spawning things. Compile and save and try again. And we'll give it 5 more seconds to see if it spawns multiple ones so we can walk over it. Should be enough time. Okay, so only one was picked up there. So now the process is really simple to expand upon this, because all you need to do is bring out like a multiples of these spawners and then play. And one of these 3 locations, which should hopefully be seeing on the screen here, will be randomly picked, and then it will spawn there. And if it's already occupied, it will spawn somewhere else. There is a slight issue though, that it could theoretically pick one of these that already has spawned something, and then it says, oh, I'm not allowed to spawn, and then it doesn't find the 3rd one here. We can add some logic for that as well. Let's go to our resource manager, and then we will do let's see, we don't want to go crazy with this. Initially there's 2 fairly obvious ways of doing this. Either you can do a loop which goes through all of the stuff, and then it tries to find one that hasn't spawned and then spawns it there. However, that will make it predictable and allow it only to be spawned in like the order that it saves the spawners in the beginning. A different approach would be to have something like every time we fail to find a resource spawner that is available, we just call this again, and then eventually it will go through them. Not sure which one is the best, because if we have a situation where all of the resources have been spawned, calling on this event again means that we would continuously be doing this chain of logic, because it's trying to respawn stuff, but it's not allowed to respawn stuff because everything is already respawned. So it's a matter of preference, I guess, here, but we could let's do the loop one. It'll be less random, but that's okay, I think. So we loop on this one. And then we want to cast it. And then if this spawner has spawned, was that not, has already spawned a resource? If this is, we need a branch for that. So if it has already spawned, we don't want to try and spawn this one. We only want to do it when it's false. So, and if we did manage to find one that is already spawned, then the true will go in here, and we have no code here, which means that it would go back to the loop body and it would go to the next item. Let's see how that works, and we'll set the timer for the respawns to something. Let's see, where did we put the time? Resource manager, I guess. No? Yes. Okay, so we should have put a variable here, because now you found out the problem with not having variables. I was looking for the variable because I expected to have one here, but we have hard-coded it in here, which is not good. So we'll call this resource respawn timer, and we'll make it compile to get default, make it 3. Then we'll start and check, and it should be within 9 seconds all 3 should have spawned in different locations. Okay, that didn't work at all. Okay, let's go back to the code. Ah yes. The resource manager is gonna go through, and just like it did with the true here, where it enters this end of the execution, it will go back to the next loop. It will do the same thing over here on the false as well. So what we want to do is actually have a return node here. That's not the one we wanted. We're in an event graph, of course, then we can't do that. So what we want to do is instead have a loop with a break. A loop with a break is a loop, just like normal for each loop. However, it has the ability to abort its execution conditions under some circumstance. So for our case, that would be the part where it has gone through and already spawned once, then we don't want to continue. And let's see if I can get this properly. It will look a bit weird in the beginning here, but we can fix that. So we drag it to the break. We can double click somewhere here, and drag it over here. And then we'll put another reroute node. And we'll go over here. Like so. And then we'll move this one around here. This one we remove. Like so. Let's give this a try. Going back to our map. We'll press play. We'll run over here. And it should spawn one every 3 seconds in a new location without running into a duplicate. So that seems to work. So that's good. Now it's easy to scale on this as well, because we have made these parent classes and we've made these classes for metal. We can just easily add another resource in here by adding a create child blueprint class and call this bolts. And let's go into that one. And for a mesh, I found a nice little package, paper box. So we can replace the static mesh with that one, like so. And then all we have to do is drag this out into the world, the static mesh, the blueprint class, resource bolts. That's not either what we want to do. We want to have a spawner. My bad. I'm sorry. So we'll take one of the spawners, we'll drag it out here. But these have a class dictated on them. So these ones are all metal now by default, because that is what we are copying from. The first one we set to metal and then we've been copying. But I can just change this one to a bolt now instead, and then run the game again, and it should be spawning the bolt when it gets to its designated part in the array, which would be the last one most likely. There you go. So you see, it's very easy to scale on this system now. You can add more resources easily, you can easily place spawners wherever you want, and it's very easy to manage. The only thing you need to keep in mind is to make sure that you have the resource manager, since it is the one that's communicating with these spawners, and without it they would not be spawning at all. If we were to remove this one and hit play again, you'll see that we're getting no spawns are getting their events called to spawn a resource, so it doesn't actually happen. So important to have the manager, the resource manager, in the world as well. It can be anywhere, it doesn't matter its position, it's just somewhere in the world. Now that we added a new resource, bolts, we need to add that to our first person character as well. So we have our let's see here, event graph, increase resource materials, and we'll just let's see, increase, there we go, and we will I can't copy it, okay, never mind, we'll do this then. First of all, we need to make some more variables. We need to have a resource bolt, make it a float because it's the amount of them, and then resource bolt max, and we'll put that one at 100 as well. And then we will copy this and paste it, and it will be renamed because it encounters a identical name here with the custom event we already had, so we just renamed this one to increase resource bolt. Let's tidy that up a little bit. There. But now we know that we have the resource metal here instead, so we need to change all the metal resources to be bolts instead. And we need to set bolts over there. To hook that up to the connection there. We need to hook this one up here, this one there. Remove this one. Get the resource from max bolts. Place it here. So there, now we have expanded upon our bolts. So now we should be able to pick up bolts as well. It should type out, well, it doesn't say bolts, but it will say that we have picked something up. And equally, since we have default on our resource, collectible resource, where are you? There. Mount a resource. Set to 0. Right, it's 0 because we have it set on children. Amount of resource 0 for that one, and for metal it should be 5, right? It's 5. So we can change this one to something else so we can easily identify it. However, there is one thing we should do, and that is, unless it does it automatically now. Where is it? Right, we haven't overwritten it yet, but let's go check the resource for metal. And you see that we overloaded this event here for this child. We did, however, add on our collectible resource that we're doing this pickup thing, and it is generally good habits to make sure that you're calling your parent if it has functionality that you want to do. So you can call your parent first, make sure that it does whatever it should be doing, and then you do whatever code you want to do. Of course, you don't need to do this. In case you want to override whatever logic is here, you can just skip this part and do whatever you want to do. And then we should do something very similar for the collectible bolt, of course. So override the picked up resource. Picked up the resource. Increase resource, but not metal. We want to have increase bolt. There we go. Like so. Okay. That's probably better. So first things first we need to try and see if we get the message typed out about our bolts that we want to pick up that are going to be 3 in number instead of the 5. There we go, it says 3 and then it says 5 and then 10 and 15. Everything is working okay, it seems. Now, okay. Let's see what this is. Attempted to access blueprint resource. These is pending kill. That's no good. Let's see here. It is the so we're trying to access a resource metal that is being despawned. So a good way to do this is probably to make sure that let's see, where did it actually appear? Assign resources picked up. Okay, let's see if we can reason ourselves to why this is going wrong. If I were to guess, I would say that immediately upon spawning the actor, it will detect that the player is standing within the volume of the spawned actor, which means it will trigger its functions and codes for picking up that actor, which means it will destroy the actor before it can do this stuff. So we should probably have a valid check here, making sure that it is valid, otherwise we should not continue to set all the other stuff like we have already spawned something and the event. Let's see if this solves the issue. So we want to stand where the... Okay, so we're getting messages about picking up metal here. So we move away. It still spawns, we press escape, and we're not getting the error anymore. So that seems to be the problem. We're spawning the actor, it's immediately getting destroyed by the collectible resource here, the overlap. It's casting, it's saying picked up, it's doing the picked up code, then it's going to its child code, which is in this instance the metal, and saying increase the metal and then destroying it, meaning it gets to the destroy before this stuff happens. And if we get to destroy it, we don't actually need to say that we have already spawned an actor because it's already gone, and we don't need to set an event up to check if it's gonna get picked up because it's already gone as well. So that's why that solves the issue. Next up, we need to actually use these resources for something. And I know that the tutorial is starting to get sort of advanced now. It's not as beginner friendly now as it was first intended. I didn't realize the scope of the functionality, and like I said before, this is part of the problem with scope creep. It's you keep adding things and then things get out of hand. So we'll try to leave this as our last part of functionality, I think. If at any point you run into the trouble of your code isn't working like the code I have, make sure to go through the video again and see if you're missing a connection at some point and that you have all your variables set up properly like I have and things like that. So take your time and go through each part. Hopefully I have described well enough each part that we're going through so that you can follow along and reason why we're doing things. But for now we need to add another blueprint. So we're gonna make another actor. We're gonna call this machine, BP machine. So this is gonna be actually a static mesh because we need some visual representation as always. And then after that we're actually gonna use the same model as this one over here. And we're gonna see, let's right click on that one, get browse to assets. There we have the line box. We go back to our machine, we replace the static mesh with that one. Now I happened to know that we have put some scaling on this one before when I was making the scene, but it's 1.4 to match it with the conveyor belt properly. So we will put this one to 1.4 as well, so it has the same dimensions. Other than that, we want to be able to unload our resources into this machine. Make sure that it only respawns things when it actually has resources available. So to do that we need to do a few things. First of all, we need to check that we have a variable for amount of metal. We'll make that a float. Then we'll make an amount of bolts. That one will also be a float. Then we need to set up some kind of way of interacting with this. And what we can do now is we can make an interface. So we will make an interface and say blueprint interface, call it API and call it interact. Yes. And we'll open that one up and we'll make a function called interact with. And yeah, that should be fine, I think. So we'll go back to our machine and go to class settings and add a interface. Search for BPI underscore and we should find it. Compile, then we get our interface over here, which we want to implement. And what we want to do here is we want to have a reference to whoever is interacting with us. So we'll add that to the interface. There we go, and input and first person character reference. Says player interacting, so it's very descriptive. Go back to the interface again. And what we want to do now is basically, first we need to query from the player how many of metal and bolts does he have. And after we have done that, we want to snatch those bolts and put it on our pile. So we will get metal, and then we want to increase resource bolts. Well, we need to do that one, but we also need to do metal. Let's see here, get bolt. There we have both of them. We want to say the amount of bolts that you have, we want to add to our own pile of bolts first. That's the first thing we want to do. So amount of bolts plus the amount of bolts that the player has. There. Second step is to remove the bolts from the player. So we will multiply this by -1, meaning reduce it by the amount that you had, basically. Since it's an add function here. Now we need to do the same thing with metal. Let's see if we can find increase metal. We're not finding the function for that. Why is that? First person character, increase resource bolt, increase resource metal. This should be perfectly fine, I think. Why is this not working? Okay, well now it's finding it. That's interesting. Anyway, if you have the same problem I have, type in metal. It seems to allow it to find it. We will clean this up a little bit here, like so. And then this one we can actually connect like so instead, so it's a little bit cleaner. We'll increase the amount of metal we have by adding the amount of resource metal that the player has. Then we will multiply by -1 again to make sure that we drain the player of all the metal that it has. There we go. Okay, that's not what I intended to do. So, okay. So now we have this event on the machine, which should theoretically unload metal and bolts onto it if we interact with it. So let's see if we can make it interact. We will go to our first person character again, and we have a trace for pickup. And what it does is we actually go to a different event. We go to our event, let's see what we call it, E for now. So this one will go and check, am I holding an object? Did we remove that? That's interesting. We need to check and see if this code still works. I might have cleaned up a little bit too much. Let's quickly check that everything works still, that I can pick things up. I can pick it up. Let's see if what happens if I try to click this one. I drop it. Okay, so everything seems to be working still. I did not clean too much, that's good. Anyway, so in the first person character we basically have this check where are we holding an object? No, then try to pick up an object. And if we are holding an object, we drop it. So we want to go through this part where we're not holding an object and make sure if we can instead deploy our materials into that one. So our out-hit actor here, we can use interact with our interface. We don't need to actually cast it to a pickup, and it's not going to be a pickup, it's going to be a machine, so it's not going to show up like that. And if it has an interface, it's going to do whatever the interface says on that class or blueprint, and otherwise it's not going to do anything and it's just going to proceed. We want to send in a reference to ourselves because we are the player that's interacting. And to debug this, we want to say something like when we have increased our bolts, we want to type out the amount of bolts that we have to see that this will actually increase. And then we'll do the same with metal and type out the amount of metal that we have. You can't drag it directly because it's different types, but if you drag it to the background first and then afterwards it will translate it for you. Okay, so what we need to do is first we need to put the machine in here. There we go. Then we go and pick something up, like a metal. There we go. Now let's try and interact with the machine. Nothing seems to happen. Okay, let's see what's happening. First person character. Interact with target. And the machine. Interact with, and it's not printing this, so it's not getting here. So let's find out why it's not getting there. Holding object false, that's what we want. Trace for pickup, pick up object, and interact with. So we could try and print out the object that we're actually interacting with and see if that's actually hitting something. This is going to look a little bit messy here for a bit, but bear with me. There we go. We go up to the machine and we click on it, and nothing is happening. Okay. So what are we missing? It must be our cast, right? Yeah, because our cast is failing. That means we're not having a BP pickup. That is what is actually where we want to hook this up. So we want to go something like this. Let's see here, the target is, let's remove that one. So we try to cast a pickup. If that doesn't work, then we'll do an interact. Either we could have just set the interact in front of the BP pickup, but this should make it a little bit clearer what's happening, I think. So let's try it again. Okay, so it's printing out a bunch of zeros. A little bit too many zeros, actually, I would say. Anyway, let's pick up some bolts. We have 6 bolts, and it's not putting any of it in the machine. Okay, more troubleshooting. Let's go to the machine. We're getting interacted with, we're getting the amount of bolts, we're adding them, and we're subtracting. Okay, maybe we should actually set our amount of bolts also, so that the value is saved. That would be useful, I think. So something like that. And then we have the amount of metal. No, we want to set it. This is the value that it's setting it to, and this is what we're doing. Okay, let's start with debugging this again. A lot of zeros, picking up metal, placing it in there, we get 50000. Okay, so we're getting the updated metals here in this object. However, we are getting multiple printouts. Let's see, machine. I think I know what it is. I believe we have a print message in these increases. Yeah, right, okay. So we should have been a bit more descriptive with our debugging. So let's see here. What kind of a string do we have? We want to create a build string. Let's see what that does. Okay, so we get does this allow us to type text as well? It seems like it does. Let's see what happens. We want to have the value in there, and we say on player. So this should say the amount of, let's do it this way. This is the increase of metal. So we'll say metal here on player. So this should make it so that it builds together first the number, so number of metal on player. That should make it a little bit more clear what's happening. We'll do something similar down here. And we'll get this and we'll type in bolts. Go to the machine. We actually bring this along with us because it was useful. So we say amount of, there's the amount of, and this is metal. Then we'll type in machine. And then do the same thing over here. So we want to have this value in here. We want to have this value as the prefix. We want to say bolts here instead. And in machine. Okay, let's see what happens now. So we'll go up here and it'll say metal 00 in machine. We could have used some spacing there. Let's go and do a few things here. First of all, we want to change the duration to something we can actually have the time to read. So 10 seconds should be fine. We'll do that on all of them. We will make sure to have a space before and after metal. And do that here as well. That should make it more legible. Go to the first person character, we do something similar. 10 seconds. 10 seconds. Space in front of metal, after metal. Before bolts, after bolts. Let's see what our debug says. Metal 0 in machine, metal 0 on player, bolt 0 in machine, bolt 0 on player. Okay, so now we pick up bolts. So now we have 3 on player. Put it in the machine. It says bolts 3 in machine and 0 on player now. It's still lagging behind a bit with the message because these are displaying for 10 seconds now, but once this expires then you can add it and it should say, oh, it should say 6 now. There we go, 6 in machine and 0 on player. Good, first part is done. Now we need to have a way for the machine to interact with the spawner of pickups, because we're gonna simulate that the spawner belongs to the machine. So we're gonna add to the machine a variable of pickup spawner ref for reference, and as a type BP pickup spawner. And now we need to do like before, we need to add at our begin play, we need to actually save this by getting actor of class. We're gonna assume for now that it's just gonna be one, but if you want to change now multiple spawners, you need to rewrite this code and have multiple classes of it and alter it accordingly. Pickup spawner. There we go, and we set the pickup spawner reference over there. So that's the first thing we do when this machine comes into being, right? So that's all good and fine. However, we need to have a way to communicate with the spawner to say if we have run out of resources, for example, that it shouldn't be continuing to push out items. So if we go to our pickup spawner, we need to make some events, custom events, pause, production, and then we'll make another one called unpause. Oh right, we need to make custom event first. Unpause production. And everything that this needs to do is basically just pause the timer or not. And to do that we need to actually have the reference to the timer which we created in the beginning here. So if we promote it to a variable and say that this is our timer ref, and then we go and use that over here, and we say pause timer by handle, and we do this one, and if not then we have the unpause timer by handle. And that is all we should be needing in this class. So whenever we call one of these we can pause the handling, the generation of the spawning of the actors. So we need to go back to our machine now and determine when do we need to pause. So to do that we do something similar to what we have done before, which is we create a event by timer. And we say a variable on this one, and we say time between resource checks, because that's what we need to do. We need to check if our resources are still okay, and then we loop, and then we can set it to something like 1 to begin with, I think. So every 1 second it'll check. Let's make, yeah, it is fine for debugging. Then we need to make our event for this. So check resources, and if amount of metal is less than or equal to 0, then we type out from the boolean here, we type out or, then we get the amount of bolts, we type in less or equal than 0 for that one as well. So if either of these resources are expended, then we need to pause. So we'll put a branch over here, and if one of them is expended, then we need to pause. So we need to use our pickup spawner ref and say pause production when it's true, and unpause production when it is false. And other than that we also need to have some sort of way of actually decreasing our amount of resources, right? So what we will do is, after we have, if we have unpaused, then we reason that we have enough resources. So what we will do is we will take our amount of metal and -1, and then we will set our amount of metal to the new value. Then we'll do the exact same thing for our bolts. So we will basically be reducing our amount of metal and bolts every 1 second. Like so, and we set the bolts. There we go. So if we were to start this now, hopefully it should not be spawning anything for us here, because we don't have the resources to do anything. And it seems like it doesn't. But if we were to go to the machine and increase the amount of resources to 10 metal and 10 bolts, it should have enough to do, I think it's going every 5 seconds, right? So we should have enough to spawn 2 items possibly. It doesn't seem to be spawning at all. Okay, another troubleshooting opportunity. Let's see here. Let's start with going to the pickup spawner and typing out when we pause and when we unpause to see if we can see something there. There we go. And pause. That didn't turn out very well. We'll do it like that. Let's see what happens now. So we start. Unpause, unpause, and then pause. Okay, it seemed like it was only enough, and we did spawn something. It seemed like it did the decreasing a little bit faster, I would say. So if we go to the machine, we will, the timer we have is 1 second. We have 10 of each. We should be going through it, checking if it's less than 0. If it is, then it's pausing. Otherwise it's unpausing. Let's make sure to check what it actually has as the amounts. See if we can see something erroneous there. So amount of metal we will be printing there. And here we'll be printing. It's a little bit messy when you debug like this, but you need to go back and clean it up afterwards when you figured out what's wrong. I think this is good practice. So it says it has 10, 9 and then 1 for some reason. So the second value got set to 1 for some reason. Where are we? Machine. So we are... Okay, so we're decreasing... Here's the error. So I'm decreasing the amount of bolts by the amount of metal that we have here. This is not what we wanted. We wanted to decrease it by 1. Let's try it again. It should be saying 10, 9, 8, 7, and we're spawning items. And as soon as it runs out of items, it will pause it, and it should no longer be spawning items. Which means that we now have to go pick up bolts and metal, and then we'll put it in the machine. Hopefully it should continue to respawn. See? Very good. The next step is to actually replace the model over here with this model. So we will do just that. We will delete this blueprint, have it marked down here, select in the viewport the model we want to remove, and replace with BP machine. And it turned out to be a little bit too big. And the reason for that is because we put the BP machine scale to 1.4, and then it has 0.14 here as well. So if we reset this, it should be fine. Other than that, we can also take this spawner and maybe shove it into the machine a little bit further. The issue with this is going to be that, well, first of all, it might not fit. So we'll see how that works out. Second part is that our conveyor belt here, volume only goes so far as to here, so it won't actually start pushing any items here. So we will have to change that as well. So we'll go to the conveyor belt, go to the viewport, and we want to increase the scale it along the red axis and make sure that it's a little bit behind it, right? Like so. This should hopefully be within the machine. Let's give this a try. It spawned something, but it's not moving it, and then it spawned the engine, so I'm gonna assume. Okay, it seems like our volume was just slightly too short, so we will increase it further. Scale it along the red axis and pull it back a little bit and save and see what it looks like now. Now it seems like it's covering the whole machine, so let's see what happens now. Okay, it's pushing out the machine parts. Very good. So now we need to do some cleaning up of everything that we've done. Remove all the debugging and stuff like that. That is all for part 5. Hope to see you in part 6. Keep on learning.